Welcome back, everyone. In this video, we're going to take a look at the program we did in the last one, which was Splitter Joiner, and write one that's a bit more professional, a bit more interactive. Let's go ahead and get started. I'm going to close this one, select it, and shut it down. I'm going to create a brand new Python 3 notebook. Now I'm going to call this one Splitter Joiner Interactive. I'll call it 01A Splitter Joiner Interactive. Alright, to get started, let's put a comment here. I'm going to import a couple of libraries, OS, and I'm also going to import os.path. What we want to do is pretty much do what we did in the previous one, but add a bit of a professionalism to it. So this video is going to be a little bit longer than the other one. First, I'm going to create a menu which will be presented to the user. We're going to print a welcome to Splitter up here. Actually, let me just, I don't need to call it, it's just a welcome message. Let's do a blank print to skip a line. Let's give some instructions to our user. You will need to specify a file name and a split size. So we'll let them decide how big they want it to be. So I'm going to let the file name be a variable and input enter a file name. Now the assumption here is that the file is in the same directory as this program. We're not making it too hard for ourselves. Let's create a buffer size, and this is going to be the integer of input. Enter the split size in bytes. So we're assuming that whatever they're giving us, if they give us 10 and they met 10 kilobytes, that's not going to work. We're going to assume it's 10 bytes. And we're going to return, this is a function, we're going to return the file name and the buffer size. Alright, so now what I'm going to do is I'm going to create, and I will need room for another function that I'll write a little bit later. I'm going to create splitter here. And this is going to look more or less just like the previous one. It's just that we will have a few more things to keep track of. I'm going to have a responses variable, responses, and this is going to be set equal to menu. Let's see what's going on over here. If I were to print responses, let's just execute this file right now and go ahead and run splitter. File name is wildlife.wmv, let's say, and if size is, let's say, 1000. And well, I already got a message. I misspelled responses, I suppose. Yes, this is responses. So I'm glad that I did this little test right off the bat. So wildlife.wmv and whatever. And you see it actually returns a tuple. That's what responses is going to be. It's going to be a tuple. Now that we know this, go ahead and cut that out. We can continue. I just don't need the print statement anymore. I'm going to use a try-catch clause, and I haven't covered that, but I will cover that in another video. This basically is Python's error handling mechanism that we are doing. It's just that I apologize. It doesn't call it catch; it calls it except. I'm thinking of Java, I think. But I'll cover a short video after this one about how to handle it. In a nutshell, what goes in the try clause are statements that we want to run. And if there are any errors, the error is thrown. The error is also called an exception. It's thrown and it goes to the exception clause. And we decide what to do with it. I'm going to let file name. And I want to point out that this file name is not the same as this one. They're different methods, different functions. I'm going to let this be respond responses sub 0 because I know that's the first thing that it returns. And I'm going to do a check if os.path that is file name. So I'm checking to see if this particular file exists in my current directory. So I'll put a note over here, if file name exists in the directory. We're going to call a method called cleanup, which we haven't written yet. So I'm going to call cleanup file name. Else, I'm not going to do anything. I'm just going to move up. And the cleanup is an underscore. Apologize. Okay. We'll deal with the exception later. For right now, we're still inside the try clause. So we're going to continue. I'm going to let my buffer size be equal to responses sub 1. As you recall, this is the first element. That's the 0th element. This is the first element that comes back. And more or less, the rest of this is very similar to the previous program that we wrote. So infile is going to be equal to open the file name that they've handed to us. And this is going to be open for reading in binary. Okay. I'm going to create a split file prefix. And this is equal to initially the file name. I'll create my buffer variable, and this is going to be my input file that read however size that they specified, however big they wanted these pieces to be. And I'll let my index be equal to 0. And then I'll start my while loop. So I'm going to say while length of buffer, so there is something in the buffer, it's not equal to 0 yet. I'm going to let the split file prefix be appended by string of I, which is currently 0. So that's going to be our first file piece. My output file is going to be opening that piece right now for writing in binary. And then we're going to take the output file and actually write the buffer to it. And then we'll close it, as we did in the previous one. You can see it's very similar. We're going to print a little period. This is our progress bar. Okay, I'll put another note here. This is the progress bar. And I'll let the buffer be the read the rest of it, the next buffer size, if you will. So I'll read the next buffer size into the buffer. I also need to increment my I, and I'll let the split file prefix be set back to the file name so it can get the next piece of the next index I added to it. So it becomes 1, 2, 3, etc. Outside of the while loop, I'm going to put a print statement, and I'm going to print split complete once the while loop is done. So now we're still not done with this because we have some information that we want to keep track of that we're going to hand to the joiner portion of this. So I'm going to create a meta file. I just called it a meta file. So I'm going to let out file be equal to open, and this out file was closed, so I can use this variable again. I'm going to open up the file name, but I'm basically creating a new file here. I'm going to create a file with the .meta extension. Oh, meat. And this is going to be a text file, so it's for writing. So if the file isn't there, which it isn't, so if the file is called wildlife, it becomes wildlife.meta for writing. And I'm going to take this file and write some information in it. For one thing, I'm going to write my split prefix, and I'm going to add a line break. And this is how you do a line break in Python. A \n is a string for line break. So it moves the pointer to the next line, and I'm going to use my out file, and I'm going to write the string version of the buffer size that was specified by the user. I convert that number to a string and write it, and I'll do another line break. Then I'll take the out file and write the actual I, the index, where it ended, because I'm going to use that in the joiner. Finally, I take my out file and close it, and I'll take the input file and also close it. In the exception clause, I'm going to put a print statement, file not found, or some other error, let's say. Okay, so over here, we were basically asking for the file name, and if they put something that doesn't exist in the directory and the file isn't here, then we're going to give that exception, basically. That doesn't exist. So if it does exist, we want to make sure that we remove the splits and stuff, so we don't have a problem of the new splits being mingled with the old splits. Let's actually see if this works. So I am going to go and delete those wildlife files in my Python directory. So I'm going to delete all of these W's. Now we do have a small problem. We still haven't written the cleanup method. So let's go ahead and write the cleanup method too. So I'm going to come up here and do def cleanup. And this takes file name as a parameter. As you recall, we passed file name to it. So again, I'm going to do a try clause with an exception clause. And what this is try to clean up the leftovers. So if anything that's left over. I'm going to take my meta file and set that equal to the file name plus .meta. As you recall, that's how we created that meta file. It was our file name. Okay. I'm going to take an input file variable and set this equal to open the meta file. Okay, and this is for reading mode. So once it's open, I'm going to take my meta info. It's a new variable. Basically, each line is part of this. I'm going to take input file dot read lines. You may recall from when I was showing you how to work with files that read lines read every file in a text file and returns a list. So each file becomes an element of the list. So I'm going to create a variable splits. This is equal to the integer of meta info sub 2. Well, let's understand what that is. I misspelled info. Well, this meta file, remember that when we write the split prefix, that's element 0, the buffer size is element 1, and the index, which is the how many splits we have, is element 2. So I'm reading that element 2 here, and I'm assigning it to splits. And I'm going to use a for loop for I in range splits. Call the OS methods remove methods, the OS libraries remove method, file name plus string I. Okay, and exception, we don't need to do anything, we'll just pass. Let's actually do a shift enter here, see if this works. I am going to run the program splitter. And what's the file name? Wildlife.wmv. How big do you want it to be? Let's say 10,000 or 100,000 bytes. And it says split complete. If we take a look, we can see that tons of stuff was created. And I'm just looking at the very end. The last one is 262. If we don't have the cleanup and we run this program a second time, and let's say instead of assigning 100,000, I say 1 million, then it's going to override the first 26 or 27, but then the rest of this remains. And that's why we have the cleanup, because we want all this to be cleaned up before the split runs again. So if I were to run splitter again and do wildlife.wmv, but this time I specify, let's say, 2 million for the file size, and go back, you notice that all the extras are not there. Those files were wiped out by the delete, the cleanup process that we put together. And it's very important for you to understand why this cleanup is so important. So assuming that we have the cleanup working too, let's go ahead and write the joiner portion of this. So we're going to write joiner. Let me come up here and put a comment up here that this says splitter. Oops. Wrong place. Over here, splitter. And I'm going to come down here and create joiner. All right, as before, I'm going to have a little menu that I'm going to be friendly with my users. Print welcome to file joiner. Let's print a line break. And let's give them instructions what they need to provide. You will need to specify the original file name. While we're at it, by the way, if I were to go back over here, you will see that there is a wildlife.meta that we created. And this is just a text file. If I open this up with, say, Notepad, more apps, you can see that it put the file prefix, the size, and the fact that the index ended at 14. Looking at this, we see that we went from 0 to 13. We have 14 pieces. So it's keeping track of that information for us. That's why it's important. So we can hand that now to the joiner as we write the joiner portion of it. So I'm going to create a file name, and this is input, asking them, what is the file name? Enter the original file name. And while I'm at it, I'm going to delete that new wildlife because we're going to recreate it. Let's just make sure that it's gone. And it is. Good. Okay, so that takes care of that. I'm going to return the file name. That's all I need to return. So I'm going to do def joiner. And this is going to also have a try exception clause. I'll do that in next video. Let's do file name is equal to the menu. Remember, the menu is returning the file name, so we just assign it again here. And let me specify my meta file. This is equal to the file name plus the meta extension. Let me not forget my dot here. Input file. My file handle is going to open this meta file. So let's go ahead and open this meta file. And it is a text file. We'll open it in read mode. Meta info, as before, is equal to the input file. That's the handle to it, at least, read lines. So we're going to read every line, and meta info will be a list that has those three elements in it, 0, 1, 2. Let me create a split file prefix to be equal to meta info sub 0. Okay. Now to make sure that that line break is not there, the line break is not there, I'm going to call the strip method. I'm going to call the strip method. Let me show you this very quickly. Let me add a cell here. If I have a string, let me just call it text. Text is equal to this is a text. And I have all these spaces. And if I were to print text, you can see that it's going to print this with all the spaces. But I can call text.strip and notice that the spaces are wiped out. Spaces include not just spaces, but also tabs and line breaks. So by calling this strip, I get rid of that line break. Okay, so that becomes the, if you recall, that when we were looking at the meta file, that becomes wildlife.wmb without the line break in it. All right, so I have that. That's great. That's the split file prefix, the file prefix that we want. The buffer size, let's go ahead and get that. The buffer size is equal to the integer of meta info sub 1. And again, I'm going to strip. Remember that this is being read from a text file, so that even though it's a number, it comes in as a string. So we have to cast it or convert it to an integer. But before doing that, we also strip that line break. And splits is just the integer of meta info sub 2. This last one doesn't have a line break, so we don't need to. Although if you put this strip, it doesn't hurt anything. I'm inside of a try clause, and I'm going to do another try right here and another except. And my try is os.remove new attached to the file name, which I already manually removed. But if it's already there, we want to remove that. You may recall in the previous video when I did an append, it simply appended it to the existing file, so it just doubled the file size. So we want to do that. What's the exception? We just want to move along. We just want to pass. So that takes care of that. That's why I needed the os and os.path. os.path was used up here in the splitter, as you recall, in this portion of it. All right, so let's continue with the rest of the joiner. Now that I have all my numbers, I can write it pretty much like it was in our initial video. So out file is going to be open the new plus the file name, and this is going to be for append in binary mode. My input file will be, remember this is the file that we're appending to, so these are the little splitted pieces. So I'm going to say open split file prefix plus string of 0 to begin with for reading in binary mode. So we read that first piece, and buffer is the actual reading. So infile.read the buffer size that was that we read from our meta file, and the index as before starts at 0. So I have my while loop. While length buffer is not empty, let's take our odd file and write the buffer value. Great. Let's print a period. This is our progress bar. End with nothing so it doesn't create the default line breaks. Increment I. And if I, remember in my video I had to clumsily count everything. Here I can just say is equal to the splits that I read, then break out of the loop. Stop. I'll let the split file prefix be equal to the meta info sub 0 again. Strip off the line break. The split file prefix is going to be appended the next index I, and my input file will be opening this new split for reading in binary mode, and finally I'm going to have the file be read in file.read buffer size. There we go. So that takes care of that, and that's the while loop. Outside of it, I'm going to take my in file and close it. So the file is closed at that point, and I'll take my out file and close it. Let's have a line break and then print files rejoined. File name is the word new plus the file name, so they know. And the exception is going to just be a print statement, non-existent file or some other error. And assuming I didn't make any mistakes, which I did obviously, then this should be okay. Let's check it out. I'm gonna come here and delete this, and I know that I have these various splits, so let's go ahead and run joiner. We got our welcome. We need to specify the original file name, which is wildlife.wmv. And it says files rejoined. Let's go ahead and see if in fact that's the case. There it is. It's the same size too, which is great. So it worked. I'm going to double click it to open it, and it is working. So here we have an interactive program that is friendlier than the previous one, but it's based on the previous one. And in a nutshell, I want you to understand that you start out by making a program to do the fundamentals, and then you start enhancing it over several iterations. And this can go on for a very long time, obviously. You can keep iterating. I hope you enjoyed the video. I am going to cover try exception clause in the next video, so see you in that one. Thank you for being a great audience, and if you're enjoying these, please share with loved ones and friends.